Hey everyone, I'm gonna show you how you can build RAG locally on your personal computer. It does not need any kind of the GPU. If you have RAM more than 2 GB in your computer, then you can run this particular model. So this is a sneak peek. You can watch this whole video to know the overall process, how you can run it on your personal computer. Let me just quickly show you the final output, how the final output you are gonna get. So here I have provided a lot of sample question. You can ask any question to your RAG system. Once you watch this complete video, you would be able to replicate this particular code. So I have asked here a question like how much revenue is there for the Google, and then it is going to generate here the final answer. Now you see that output is coming in the chat GPT format, the one thing. The another thing, you can see that how fast this output is. This is a super the fast output. All right, and this is going to be very helpful. So for this particular things, it does not provide the any context. So it says that I do not have any explicit number here, but I can say that how much revenue is there for Google in, let's say, September. I ask here September 2024, it should be able to answer here. All right, so it says that okay, I got the output, and then it says that okay, the 3 month ended September, there is this much the revenue here. All right, so something like that, you can ask any question, basically any question, right? So I have provided the sample question, but you can bring your own question. We'll be doing this RAG on this Google document. This is the financial document submitted by Google to the United States Securities and the Exchange Commission, and this is something like that you will be getting the final output. So overall, this lesson, basically this tutorial is going to be super helpful. Let's go ahead and get started with the building this RAG locally with the DeepSeek, and you can see that DeepSeek is a very small model. It is going to be it is going to take like 2 GB or less than the 2 GB RAM on your computer. I have one request to you. Please do like this video and subscribe this channel so that you can get update whenever I publish new video on the RAG and the large language model. All right, let's go ahead and get started with the coding part of building RAG locally on personal PC. I'll see you then. Hi everyone, let's go ahead and get started with the building RAG locally on a personal computer with the DeepSeek R1 1.5 billion model. So if you do not have a GPU, if you have a small computer with 4 GB RAM or more than 4 GB RAM, then you can simply run DeepSeek R1 1.5 billion model on your computer. Before we get started, let me tell you a couple of things about this tutorial. That the data set which I'm going to use in this tutorial, that is available at LangChain RAG dataset. Along with that, you need to download your Ollama, and also you need to pull your DeepSeek model, and the code file which I'm going to use in this lesson, that is available at my GitHub repository. So here is the link. You have LangChain RAG dataset, and this particular financial dataset I'm going to use here, and thereafter you can get the code module number 5 here, Ollama chatbot, and there are the tutorial which I have covered in my previous videos, and the link for that tutorial is given here. I have so many local LLM tutorial. Those tutorial you can watch. I would suggest you to watch Run DeepSeek R1 model locally with the Ollama. Here I have shown you how you can install Ollama. If you already have Ollama, then it is fine. And other than that, we will be using here Ollama nomic embed text to embed our text data into our vector space. And thereafter, we will be using here a docling library. And this docling comes from the IBM. So we'll be using this docling to convert our PDF document into a markdown document. All right, and then we'll be also using here a langsmith. So we'll use langsmith to get the tracing of our LLM so that we can know that what is happening behind the scene. All right, let's come back here to the code, and in the code part you will see I have here RAG dataset. Inside that I have my document, Google 10Q document. So this is a financial document submitted by Google to United States Securities and Exchange Commission. This is known as a form 10Q. So in the form 10Q, Google tells about its financial status to the United States government, that what is the current financial status, how much earning Google has done, and what are the strengths and the weaknesses of the Google. All these things are presented here. All right, so we'll be using here a doclink to read this particular document. We will convert this document into the markdown documents. All right, perfect. Having said that, let me just show you how you can get started with the code. Now in the coding part, you will see here the two things. One is the document ingestion, another one is the retrieval and generation. So in the document ingestion, what happened here, you have your document and then you need to extract your text data. There are so many libraries available. You can use any of these libraries to extract your text data, and thereafter you need to get the chunking. All right, so basically you need to chunk your text data into a smaller chunks, and then you need to embed these text data, and then finally store these text data as embedding in the vector database. We'll be using here a FAISS vector database, that is the Facebook AI similarity search database. So this is the one step. Then the another step, once your document is ingested into your vector database, thereafter you need to use here again your questions and the Ollama embedding, so that you can find out the similar documents or similar chunks from your vector database, and then you can pass these chunks to your LLM. You can use any kind of the LLM, just name it any LLM you can use, like the Llama, Pi, DeepSeek, or any kind of the LLM you can use here. So we will be using here a nomic embed text, and we will be using here a DeepSeek R1. Let's go ahead and come back to our Ollama here. So the first of all, I'm going to show you how you can pull nomic embed text. You need to come back here. You need to make sure you have installed Ollama. Thereafter, you have to pull it, Ollama pull nomic embed text. Thereafter, you have to also pull your DeepSeek 1.5 model, and here I come 1.5 model, and thereafter I just copy this whole code from here, and then I come here and then I search here Ollama pull and DeepSeek R1 1.5 billion model. You have pulled these model on your local computer. Once these models are pulled on your local computer, thereafter you can get started with using these models with the LangChain here. And there are so many libraries which you have to install here. So these are the library which you need to install, like LangChain, LangChain Community, Fire CPU. Thereafter you have to install LangChain Ollama, Python.env, doclink, and the doclink LangChain. Probably this one you do not need probably, but yeah, all these libraries are there which you have to install it here. I have also provided here a sample RAG question for your reference, but you can bring your own question as well. So like the questions are here, how much revenue is there for Google? Currently I'm using here a Google document, so I named this company. Otherwise you can use any document and you can ask any relevant question. Then you have here, what is the net income for this quarter? And then what are the key drivers contributing to its increase or decrease? And then what is the guidance for the next quarter, and so many other questions here. So these are the sample question. You can ask your own question. Just for simplicity I provided these questions. You see, the person who are not in the finance domain, for that particular person understanding this document could be quite difficult, and going through with this 53 page of the document is again a quite headache. So if you build here a local RAG, then you can simply ask a question, any question out of these 53 page of the document. All right, having said that, now I need to run this environment. I need to first set here environment variables. So what are the environment variable I'm currently using? So I have a LangChain API so that I can do the logging of my logs at the Langsmith, and this is going to be the project name, and here is the Langsmith endpoint, and then LangChain tracing version 2 is the true. So this one is going to make sure that we get the log of our chain at the Langsmith build RAG. So I ran previously, now I can see here the output. All right, and this is something like that we are now going to get here. So the first of all, what I do here, I have to make sure that I have imported this properly. So I run this, it says that true, that's mean it is loaded. And this makes sure that if you have a duplicate libraries, KMP library, then it will make sure that you don't get any error. Then these are the necessary packages which we import here. So this is related to our FAISS vector database, and this one is related to our LangChain core prompt output parser and the runables, and this is going to be used for markdown splitting, and this one is going to be used for the Ollama and this one will be used with the nomic embed text embedding, and this will be used with the DeepSeek R1 1.5 billion model. And here you have the document converter. So this is for the docking. That's all you have to take it here. I mean, you have to do here. You need to just run it. One more thing I wanted to tell you here with the DeepSeek. So total size taken by DeepSeek model is 1.1 gigabyte. That means any computer with the RAM of 2 GB is more than sufficient to host 1.5 billion DeepSeek model. It is pretty much good model. It can run properly without any issue. And overall, these are the steps which we are going to follow. So the first of all, we will be doing a document conversion. Thereafter, we'll be splitting our markdown into the chunks, and then we'll be doing here embedding and the vector store, and then we will be formatting our documents for the RAG, and then we will do our final setup, and thereafter finally we will put everything together. So this is the overall process which we are gonna follow here. In the document conversion, let me just show you through our block diagram agentic RAG what happened here. You have your document here. Let me just zoom it a little bit so that you can understand. All right, so you can use any of these libraries to convert your document into the text data, but the docling markdown megaparse are widely used libraries which converts your PDF into the markdown, and thereafter a smaller chunks are created, and then through the Ollama embedding is generated and it is stored in the vector space. All right, once these things are done, then in the next step we can use our question, and then we can find out the similar chunks which we had embedded here in our vector space, and then we can pass those to the LLM. So this is the overall process. Let's go ahead and first build document in JSON part, and then we will come to the retrieval part. All right, so here for the document conversion, what I have to do here, let me just know how to do, yeah, here. So in the document conversion, so the first of all I have to load my document here. So I have a code here like load and convert document, where I'm going to provide a path, and then this document converter is getting used from the docling, and then it is going to convert the document, and then finally it is going to return the markdown file here. All right, thereafter this is the file path. So basically this is the document which I'm going to use. You can pass here any kind of the document, be it online document or the local documents, any document will work here. And then here you have a markdown content. All right, let's go ahead and run this. After running this, you can check that your markdown content here basically. So what you have here, first time if you run your docling, then it downloads so many the packages from the Hugging Face, so it might take a little bit time. Otherwise it is going to be super fast. All right, so it will convert this whole document into a markdown, and then we can visualize our markdown here. Alright, so the document got converted into the markdown. Now you can visualize here markdown document. So this is a complete markdown document. Let's come to the text editor and just copy this whole thing, and we are going to see it here with the markdown viewer. So I open markdown viewer, and in the markdown viewer I just paste this document. You can see here that all the headings you have got here. As you scroll it down, you can see all these the table contents are also extracted here correctly. So converting your document into the LLM is going into the markdown is going to help your LLM understand markdown document better than the simple text document, because in simple text document these structures are not maintained. Then in that case your LLM might get confused. So always try to convert your document into the markdown, and with that you will ultimately increase the accuracy of your model. Otherwise your model might not perform, it might get hallucinated and it might get confused, all right, if you put a lot of documents there. So once you have your document into the markdown, thereafter what you have to do here, you have to split your document. So basically what we are doing here currently, we have our document. Now we need to split our document in a smaller chunks. Now the splitting, there are so many type of the splitting, but in our case we will use here markdown splitting. Why markdown splitting is important? Because you see, if we split our data, let's say this data into a smaller split, something like this, let's say a random split, one split becomes this one and another split becomes this one, then this is not going to be helpful. So what we will do, we will split our markdown into the headings. Basically, we will say that, okay, this is one split, and thereafter the another heading is going to be the one split, and so on. For example, in this heading, this whole thing will be a single split. Instead, randomly we decide that, okay, this is one split and then this one is one split. That is not gonna helpful. So what we'll do, one heading is going to be one split, and for that we will use here markdown content splitter. So for the markdown content splitter, we have already imported markdown header text splitter. That part is already imported, and then we are going to use heading 1, 2 and 3. So heading 1, 2, 3 means any heading which starts with 2 hash, 1 hash or a 3 hash, that is going to be splitted as a single chunk here. And thereafter I return that splits, and then here I get that particular chunk. Let's go ahead and run this, and now I have got the chunk. Let's go ahead and print some random chunks. All right, so here I have this particular chunk. Let's go ahead and just try to visualize this chunk in our markdown viewer and then see if we have got a correct chunk. So for that, chunk number 13 or 14, which is at index 13, you can clearly see that we have got here a perfect output. Otherwise, if we do random chunking, let's say something like this is, the removed, then in that case it is going to create a problem here. All right, because now you do not have here a complete data. All right, now let's come back to our coding part. I hope that you have understood this whole process, why I needed to do the markdown chunking. Let's go ahead and just comment this so that we can save some space. All right, so we have we read our document, we loaded our document, we got markdown chunking. Now all the chunks are ready here. Now we are ready to embed our data into the vector store. So chunking is ready. Now we are going to create here a method that is going to be like setup vector store. In that vector store, we pass our chunk, and then through the Ollama embedding, we read our chunk. So we have our base URL here, and then here is our model. Then this is going to read our document. And then we have got here a single vector, and thereafter, so why the single vector? Because you see, the first time when you store into a Facebook AI similarity search database, that is a FAISS database, in that you have to tell that what is the size of vector. So I just provided here some random string, and for that I got a vector, and then I got a length here, and then I told my FAISS that, okay, this is the length of the vector, so that it can create their index for that particular size. And thereafter I have got here my FAISS vector database. I pass my embedding function that comes from here, and then the index doc string is going to be the in-memory doc string. So basically, once embedding is generated, that is going to be saved in the computer RAM itself. And then you have your vector store, add document. So here I add all the document, and then I return here a vector store. This one is going to be used to map our document ID with the index ID of the FAISS database. Let's go ahead and run this method. Once you run this method, thereafter you can just simply get the vector store. So I call this setup vector store. I pass all the chunk data, the previously which I have generated through the markdown splitting, and then I get here a vector store. Thereafter I get a retriever. So this retriever will be used along with the LangChain chain, and the type of the search I'm going to use here MMR, that is maximally margin relevancy search. And thereafter you have here search keyword k is 3, that means it is going to retrieve top 3 matching document. All right, so this is going to first generate the vector database. It might take a while, and thereafter it is going to produce the uh, retriever for you. And then if you check here how many documents are indexed, that you can check here, and you can check the length of your chunks. With that you can verify if all documents are indexed in your vector database. I see 159 chunks was there, length of chunks, and I can see that, okay, 159 total 159 the documents are chunked in the vector store. Thereafter I come back here, I can just show you how the documents are retrieved here. You can just simply run it, and then you can just check your documents here. So with this I can clearly see that, okay, I have here this document, and here I have this one, and thereafter I have this one. So I can see here all the document which got retrieved okay, through the Facebook AI similarity database. You come here, now you notice document ingestion part is done. We got a vector database, and that vector database I get as a retriever, and thereafter I ask a question, and then through the Ollama embedding is generated, then through the cosine similarity is matched, and thereafter you get here the chunks here. There are the matching chunks, and then you can pass these matching chunks along with your question to the LLM for a final answer. All right, perfect. Let's go ahead and combine these chunks together so that we can get the target output. Okay, I mean overall context. So with this, what you will do here, you will combine the content of this document, and this document. So basically content of all the documents together so that you can get here the final content, and that content is going to be used as the context basically. If you just run this, now you can see here output. All right, if we copy this whole output and we can visualize this into our markdown viewer, you can just understand that overall output. All right, so there are three headings. These headings got extracted through our retriever. So we asked about the revenue of the Google, and it says that okay, here is the revenue. So basically whatever the chunks it got here, all these chunks have a relevant information regarding the revenue. All right, once you get these chunks, then you can pass these chunks along with the question to your LLM for final answer. All right, perfect. Now what I do here, I just comment this one so that I can save some space. Along with that, I'm just going to comment this document as well so that I can save some space. Now, I hope that you have understood till now everything. Now we have reached at the stage where we can set our RAG chain. That means if you come here, you will see here document ingestion part is done, and till this part we are done here, basically retriever and the chunking. So these chunks are retrieved. Now we need to build this particular part where we are going to build our RAG chain, where these questions will go inside this chain and these chunks will go inside the chain, and the LLM will take these context and these questions together, and then finally it will answer the question. So that is going to be set up the RAG chain here. This is going to be pretty much simple here. The most important thing here in the RAG chain is a prompt. So basically how you set this prompt, that matters most here. So I say your assistant for question answering task, use the following pieces of the retrieved context to answer the question. If you don't know the answer, just say that you don't know. Answer in bullet points makes your answer is relevant to the question and it is answered from the context only. So basically this says that okay, whatever the question you answer here, always make sure that your questions are answered. I mean, this question is answered from the provided context only. Do not hallucinate. Basically, this whole prompt is trying to say to LLM that do not hallucinate. Thereafter, I get my DeepSeek 1.5 billion model here. As you know that I have already pulled DeepSeek 1.5 billion and nomic embed text already. And thereafter I get here a prompt template, and then here I build my chain. So this whole thing what you see here, this is actually the chain here. So what you can say that okay, this you can say that this is going to be your chain, and then finally you can return this chain. So in the chain what is happening, you first of all pass your context and the question. This context and question is going to be filled here. So in the final prompt you will be having question, whatever the question you ask that will come here, and the provided context will come here. All right, thereafter you have your model here. Otherwise what you can do here, you can provide, this is going to be your question, and then you can provide here your context, and then it is going to provide your answer here. All right, so here is the context, and then it is going to provide your answer. All right, so this is the overall chain, and then it returns this chain. Once this thing is done, now we are going to put everything together. So we have seen everything one by one. Basically we have loaded the document, so this thing we will also take there automatically, and then we have splitting the markdown content into the chunks, and thereafter we have embedding into the vector space, and thereafter we have formatting our documents for the RAG, basically combining everything together, and then we have here setting up the RAG chain. So all these things we have. Let's go ahead and put everything together. So this whole thing is one time process. All right, so like you have your source document. Thereafter, you need to get the markdown content through this method, which we have already implemented. Thereafter, you need to get the vector store, and then you get the vector store retriever, and thereafter you get finally your RAG chain here. All these things are gonna be one-time process. So you just need to run here. The first time you run, it is going to convert your document into the markdown, then get the chunking, get the vector store, get the retriever, and then the RAG chain. Once one time process is done, thereafter you can start asking the question. All right, and that you have to run into a separate cell, because in this cell if you run, then that is going to be that is going to take a lot of time, because every time it will generate the vectors. So here I have a separate cell, in that I have all the questions here. So this is the sample question. You can bring your own question, you can ask any question whatever you want. Then in this question, what I do, I have got RAG chain here. RAG chain, we already know that this is the overall chain process where it takes the retriever, question, prompt, template, model, everything. All right, then it passes there. I'm using here stream mode, so basically it will print the output into a chat GPT format where a running output will be printed, and this is going to be the question. Let's go ahead and run this and then evaluate this, then you will get to know that. So this is the question. The one more thing, as I told you that we have already done setup for environment variable. That means whatever chain output is coming here, then that should also go to the langsmith here, so we can actually see our log here as well. So this is runnable sequence. In the runnable sequence, you will notice this is the input which is currently running, and here is the vector store. The output of the vector store, you can clearly see that it has got these documents from the vector store. Thereafter, after the vector store, then we had done their formatting of the document. Then you can see here everything is combined together, and then you have got a final chat prompt template. In the chat prompt template, you have your question, and thereafter you have your final context here. And then your chat Ollama gets this particular things here, right? So like this. So you have this everything here. Now, if you remember that we had started with UR assistant for question answering task, etc., and then we had provided here a question. Now you can clearly see that question is currently inside our prompt, and thereafter we have our context. So whatever the context we got from our RAG system, then those context goes here, and then finally it generates the answer. And that answer we see here, first it thinks and thereafter it generates here a final answer. All right, you can get here from the str output parser. Let's go ahead and see that in our code how we get the output. So this is the output in our code. First it thinks here, and thereafter it provided here final output. So as of September 30, Google has 86 billion remaining in performance obligation or revenue backlog related to Google contract. This backlog is etc, etc, and all these stuffs here we have. Let's go ahead and ask the another question. So we have here another question. What is the net income for this quarter, and what are the key drivers contributing to its increase and the decrease? So it starts thinking that, okay, what I have to do here. So it says that I need to figure out the net income of this quarter, and then looking at the context provided. Wait, hold on. The other income context seems to be about external factors, and then it talks about the September 30, 24, and then so many other numbers it talks about, and then finally it provides here final output. So the final answer is here. For the 3 months ended on this, Google Cloud reported net income this much, and there are so many other things. So here it says the key drivers contributing to the income like revenue growth, cost and expense, operational efficiency, and other factors. You see here for the person who is not like in the finance domain, for that particular person, understanding this whole document could be a difficult part. But after building this RAG, this is going to be super easy for a person. The person can just ask a simple question, and then your DeepSeek model is going to answer your question. So this is a very good reasoning model actually. Now you can ask here another question. So in this question I have here, has the company provided guidance for the next quarter or a fiscal year? If so, what are the expected revenue and the profit margin? So it says that no specific guidance provided. So we can say that, okay, maybe we do not have any specific guidance. All right. Thereafter, what you have to do here, you have to ask here the another question. So sometimes you see here that if something is not present in the context, then your LLM is not going to answer, and this is a very good thing actually. Now in the another question, which business segments contributed most? So basically I want to know that the contribution segment wise. So basically which particular segment is contributing a lot in Google revenue here. So it is putting a lot of thought behind the scene, and thereafter it will produce here final answer. So I'm just waiting here so that it can produce the final answer. Now I can see here it has provided here a final answer. The business segment that contributed the most to Alphabet was the United States. In those in 2024, the segment accounted 49% of the total revenue and increase, etc. All right. And the other segment, if you go through with this thinking process, then you can know that here there are so many things which is actually contributing. But if from the technology point of view, then you can also ask that questions from the technology point of view, that which particular the segment is contributing most here. All right. For example, which business segment, all right, which you can say that technology business segment contributed the most to the company's revenue. All right. So it can ask that, okay, Google services contributed this much, Google Cloud this much, and other things, right? So basically you can ask this question that, okay, the Google Cloud segment contributed so much and its percentage actually increased. So basically Google's cloud services are contributing a lot to its to its overall revenue. I hope that now this is very much helpful to you. We have built here RAG system. You can run this particular RAG locally on your local computer. All right, so this is all about in this lesson. I'll see you in next one.